All right, welcome back to the deep dive. Today we're getting into a physics paper that's really pushing some boundaries. It's pretty mind-bending stuff.
It really is. It's a theoretical article, and it asks this huge question. Does quantum collapse create space-time?
Yeah, that title alone just stops you, doesn't it?
It does, because normally, we think of quantum stuff happening in space and time, like space
Mm.
and time are just the background, the stage.
Exactly, they're just there. But this paper flips that completely. It asks if maybe space-time itself is like built by these quantum events.
Uh-huh. So that's our mission for this deep dive, right?
Yeah.
To unpack this idea. It's speculative, definitely, but fascinating.
Absolutely. We want to figure out what it really means. This suggestion that space and time aren't fixed, but are, I guess, constructed piece by piece by quantum mechanics.
Yeah, let's get into it.
Okay, so where does it start? What's the core concept?
It really kicks off with the wave function. Now, you probably know the wave function that describes a particle state, right?
Mhm.
Like the probability of finding it here or there.
That sort of blurry cloud of possibilities for an electron, for example.
Exactly that. And the standard view, the textbook view, is that cloud exists within a pre-existing space.
Okay.
But this article says, hold on. What if the wave function isn't just describing potential locations in space?
Mm.
What if it's describing the potential to um, generate the space itself?
Whoa.
Okay.
Okay. So the wave function is about making space.
Potentially making space, yeah. And then the key moment is the measurement, when the wave function collapses.
Right, when the particle state gets fixed, you find the electron here.
Yes. And the article proposes that this collapse doesn't just fix the particle's properties, it's the event that actually creates the specific bit of space around the particle.
Okay, hang on. Let me just process that. So it's not like the electron was somewhere in space and we just found its location.
No.
It's that the measurement itself, the collapse, it makes the particle pick a state. And doing that also brings the space it's in into existence right then.
That's the really radical part. That's the departure. They use this painter analogy, which helps a bit.
Correct.
Think of the wave function as a painter with like several sketches, several possible drafts of a scene.
Multiple realities almost.
Kind of. Until the final version is chosen, that's the measurement. All those drafts are just possibilities.
Right.
When one draft is picked, the others just vanish. And that chosen image, which is the particle plus its surrounding space, is created in that very act of selection.
So space isn't the canvas. It's part of the painting that gets created.
Exactly. It really challenges our gut feeling that space is just this fixed, passive, empty container. It suggests space is dynamic, created.
Wow. Okay. So if space-time is being generated like this by quantum collapse,
Hmm.
how does that fit with, Einstein? General relativity, where mass and energy curve space-time.
That's a great question. And they don't see it as separate. They actually suggest this might be a deeper foundation for it.
Really? How?
Well, remember the core idea of general relativity.
Yeah.
Mass tells space-time how to curve.
And space-time tells mass how to move. That feedback loop.
Exactly, that classic feedback loop.
Yeah.
This article proposes something similar, a dynamic loop, but it starts, earlier, deeper, at the quantum level.
Okay.
Their picture is kind of like this. First, you have quantum interactions. These define the wave function.
Right.
Then, that wave function doesn't just describe possibilities in space-time, it actually generates a piece of space-time when it collapses.
The creation step.
Yes. And then, that newly created bit of space-time influences how other particles nearby interact, binding their wave functions and so on.
Ah, I see. So the quantum interactions are the engine.
They're suggesting they are the engines creating space-time, not just happening within it. And this is where they see a potential bridge, maybe, a way to unify quantum mechanics and gravity eventually.
So instead of mass curving existing space, it's
Yeah.
the fundamental quantum stuff, the interactions that are building the space-time geometry in the first place.
That's the essence of it. And if you accept that, even just to explore the idea, it forces you to rethink, well, everything. Especially things like forces.
Forces like electromagnetism, gravity, how do those change? We usually think of them as pushes and pulls acting through space.
Right. But how can a force act through space if the space itself is being created by the interaction?
Yeah, it's tricky.
So the article suggests forces aren't fundamental things acting within space-time. They're more like emergent properties, descriptions of how space-time is being dynamically generated or shaped by particles interacting.
Okay, give me that electron example again. Two electrons, they repel each other. Normally we say that's the electromagnetic force.
Right, pushing them apart through space.
So how does this article explain that repulsion?
In this framework, the interaction between those two electrons' wave functions causes the space between them to sort of dynamically expand. It's being continuously generated outwards between them.
So the feeling of repulsion is actually space expanding between them.
That's the idea. What you measure or observe as repulsion is just the effect of this ongoing space creation happening specifically between the particles.
That is wild. And attraction would be the opposite.
Presumably, yes. Maybe for particles attracting each other, the space generation is happening more vigorously outside them, sort of pushing them together.
So forces aren't fundamental actions, they're just descriptions of the changing geometry of this generated spacetime.
Exactly. Emergent phenomena arising from the dynamics of spacetime creation itself.
Okay, my head's spinning a bit, but this is where it gets, like, really relevant to just existing. If one particle interaction can create a tiny bit of space, what about this room? It's full of air, furniture, me, you.
Right. The complexity scales up incredibly fast. In any real situation, you have, well, an almost unimaginable number of particles constantly interacting.
Trillions upon trillions.
And the article suggests every single one, every air molecule, every atom in the table, every particle in your body is participating in this process constantly.
So, the space I feel around me right now, the space I'm moving through, it isn't some pre-existing void.
According to this idea, no.
It's the collective dynamic result of all these countless particles generating tiny bits of space-time through their interactions all the time.
That's the picture they're painting. The smooth, seemingly static, macroscopic space-time we experience is an emergent property. It's built from the ground up, moment by moment, by these fundamental quantum events.
Which brings us back to quantum weirdness, like superposition.
Exactly. We know particles can be in superposition multiple states or places at once until you measure them.
Yeah, like that crazy Elitzer-Weidman bomb tester experiment, where a particle can, like, know something without seemingly interacting directly.
Right, because it explored multiple possibilities in superposition. But then you scale that up. Think about Schrodinger's cat. A microscopic object in superposition.
Dead and alive.
Theoretically possible, maybe, if you could achieve perfect isolation, but practically impossible here on Earth. There's too much interaction, too much measurement happening constantly from the environment.
Which kind of highlights the big question this article bumps up against, right?
Yeah.
Where's that line? The boundary between the quantum world of superposition and collapse and our everyday classical world.
Precisely. What counts as a measurement? What interaction is significant enough to trigger this collapse, this creation of space-time?
And is the measurement itself the moment that piece of reality, that bit of space, springs into existence?
That is the profound implication, yes.
Yeah.
And the speculation goes even further.
Further, where else could it go?
Well, they use this framework to tentatively think about something usually considered outside physics entirely.
Yeah.
What about before the Big Bang?
Before space, before time. How can you even talk about before time?
Maybe before isn't the right word in a temporal sense. The article speculates about a state without space-time as we know it, a kind of timeless pre-reality. In this pre-reality, quantum mechanical interactions might have been occurring, just interactions, and space-time itself emerged from those interactions.
So the Big Bang wasn't an explosion in space necessarily.
But potentially the moment space-time creation ignited, emerging from this more fundamental, timeless, spaceless substrate of quantum interactions.
Wow.
That's the truly audacious proposal. They suggest the concept of becoming this moment-to-moment emergence of existence might be more fundamental than space or time.
It's like you said with the painter, but here it's like the universe isn't a movie being projected onto a screen called space-time.
Yeah.
It's like the projection process itself is generating the screen, frame by frame, instant by instant.
That's a great way to put it. That's the analogy they use, and it captures that dynamic creation aspect. In thinking this way, viewing forces and interactions as the generators of space-time, it opens up a potentially new path for unification.
Ah, the hunt for the theory of everything, bringing gravity together with the other forces, electromagnetism, the nuclear forces.
Exactly. We have general relativity, which describes gravity as space-time geometry, beautifully. But fitting the other forces into that geometric picture, that's been the massive challenge.
Leading to things like string theory, extra dimensions.
Really complex mathematical frameworks, often hard to test experimentally. This article offers a different angle.
How
It
so?
suggests, what if gravity and electromagnetism aren't just happening on the stage of space-time, but are in fact fundamental processes creating that stage?
So they're more fundamental than space-time itself.
That's the suggestion. If the forces are the engines building space-time, maybe that's a more direct way to see how they're all connected, based on this principle of becoming and emergence,
Yeah.
without needing extra hidden dimensions.
Okay. Let's just try to sum this up. This is a huge shift in perspective they're proposing.
It really is. The absolute core idea, the main takeaway, is that space-time isn't the fixed background we always assumed. It's not a container.
Right.
It's something that is actively, continuously built, generated by fundamental quantum events, by wave function dynamics, by interactions, by collapse. It flips everything around.
It really makes you question how much we actually know, how foundational our current physics really is.
Absolutely. And the article itself nods to this, mentioning Hermann Minkowski.
Right. He formulated the mathematical concept of space-time just before Einstein really ran with it in relativity.
Exactly. It was like the dawn of a new understanding.
Mm.
And this paper kind of evokes that same feeling that maybe we're on the cusp of seeing things in a completely new, deeper way. There are always new dawns in science.
New layers waiting to be found.
Potentially.
And this specific idea that space-time is generated moment by quantum interactions. I mean, it leads to some wild thoughts, doesn't it?
It certainly does.
If quantum processes are involved, and some people speculate quantum effects are linked to consciousness, does this framework imply that our observation, our consciousness itself might play some role in, I don't know, shaping the reality we experience, the actual space?
Well, that definitely pushes us right to the edge where physics meets philosophy. It's a profound question that arises naturally from this line of thinking.
Yeah, a really profound place to pause. This has been quite the deep dive, exploring a truly radical, though yes, speculative proposal.
It's definitely out there, but thought-provoking.
Thinking about space and time not as fixed entities, but as dynamically created, emergent properties. It really does change how you view the universe.
It opens up entirely new ways to think about fundamental physics, that's for sure.
Well, thanks for joining us for this deep dive into the possibility that quantum collapse creates space-time. Definitely gives you something to think about. Keep exploring and keep questioning.